Hello everyone. This lesson is the start of a new overall topic, circles, and specifically we're going to talk about equations of circles in the coordinate plane. So, circles. You've probably worked with circles before. So here's a circle. And remember, we can talk about the center of the circle, right, the point in the middle. And then we can also talk about the distance from the middle, the center, to the outside. So like, for example, this distance right here. And remember, that's called the radius. So we label it R for radius. Also remember that if we went all the way across, so like this, then the whole distance across the circle would be called the diameter, right? And we often label that D for diameter. But today we're going to talk about circles in the context of a coordinate plane. So circles on a coordinate grid like this. And this is kind of useful because the numbers now allow us to talk about the circle more specifically. So for example, where's the center on the circle? The center is here, right? And we can give that a specific name, right? Like what point is that in the coordinate plane? So starting from the origin, we go right 2 down 3. So we say the center of the circle is positive 2, negative 3. And then this particular circle happens to be nice in the sense that the radius seems to be a clean number. So from the center, the outside of the circle, it's not always going to be clean, but this particular case, it looks like it's 4 units, right? So we say the radius here is 4. So that's a circle on the coordinate grid with center 2, negative 3, and radius 4. Now, in your previous work, you've probably graphed different kinds of equations in the coordinate plane, right? And it turns out there's a way to do that with circles, but the equation's perhaps a little more complicated than you've seen before. So here's a quick example. So I've typed this complicated equation here in Desmos, and as you can see, it creates a clean circle, right? In the coordinate plane. But this equation's kind of complicated, so let's see how it works. So first off, note that a lot of the equations we work with have this kind of format where y is by itself on one side. So y equals with only the y on that one side. And also, that's the only place that y shows up. So then the other side of the equation is some expression involving x, right? But in general, equations can be more complicated than that, like with equations of circles. So again, here's that example for the equation of a circle. And notice that, first of all, it's not a y equals sort of equation. Y is not by itself on one side. And so if you look on this whole side, x and y both show up, right? So x is here, and then y is there. And then the right side over here is just a constant. In general, it could be more complicated. So when we talk about the equation of a circle, we're going to be dealing with equations that are a little more complicated, more general than the equations that we typically see. So here's the general form of the equation for circles. And then we have an example, a diagram off to the right. But the general form goes parentheses x minus h, close parentheses, squared, plus parentheses y minus k, close parentheses, squared, equals r squared. And so the question is, what are all these letters, right? What's going on? So first off, know that the x and the y are always just going to stay x and y. So then the question is, what are h, k, and r? And so r seems easy. R is just the radius, right? So h and k are actually the coordinates of the center of the circle. So h is the horizontal coordinate and k is the vertical coordinate. So we say for a circle with this form, we say that a center has coordinates h, comma, k. So let's say we want to find and write out the specific equation for our example over here. We have to figure out what r, the radius, and hk, the position of the center. We have to find those things out, right? So looking at the circle, it's kind of similar to a circle we saw earlier, but a little bit different. Looks like the middle is, going from the origin, looks like the middle is right 3, down 4. So we say that the center of the circle is positive 3, negative 4, right? And then again, this circle is nice in the sense that the radius seems pretty clean. Looks like the radius here is 5. Okay, first off, we know that we're going to plug in 5 here for r, because that's the radius. But then notice that the coordinates of the center for our circle are 3, negative 4. So that means 3 is h, and negative 4 is k, right? H is the horizontal coordinate, k is the vertical coordinate. And so we'll be plugging in positive 3 here and negative 4 there. So now let's go ahead and actually write out the specific equation for this specific circle on the right here. We have x is always going to be x, minus h. So again, what was the horizontal coordinate of the center? Positive 3. Then all of that squared, plus y is always going to be y, minus, and here we have to be careful with negative numbers. So k is negative 4, right? So you plug in negative 4 here, and we get y minus negative 4. And we could do that like this. That looks weird. So whenever you're doing minus a negative number, we can simplify that, right? We got a double negative, so really we get y plus 4 squared. And so we plugged in negative 4 here. Y minus negative 4, we can actually just write as y plus 4. And then finally on the right side we have equals, and then r was 5, but we have to square that, right? R squared. So 5 squared is 25, and we're done. This whole thing is the equation for our example circle in the diagram there. Okay, so now what about going the other way? As in, what if they give us the equation already, but now we need to produce the graph? So this example says, consider the circle defined by x plus 5 squared plus y minus 1 squared equals 16. Name the center and radius of the circle and then graph it. So again, we've got our equation here. And we need to find the center and the radius, and finding those will help us graph it. And remember, the center is a point, right? So we're going to find coordinates for it, right? Something, comma, something. And then the radius is just a number. But we have to be careful with positives and negatives, like before. So here it says x plus 5, y minus 1. But remember, in the general equation, we had x minus h for the horizontal position and y minus k for the vertical position, right? So notice the vertical position is easy. Y minus k, what would k have to be for us to get y minus 1? Well, k is just 1, right? So positive 1 here. But then what about x minus h? Well, in our specific equation, it's not minus, it's plus. So you have to notice, it's like, oh, they must have gotten plus 5 by doing x minus a negative number for h, right? So kind of like what we were doing in the previous example, this tells us, okay, this should be x, and then h will be a negative number to get plus there. So h is actually negative 5. And that's our center, negative 5, comma 1. What about the radius? So in the equation it says 16, but note that that is not actually the radius. 16 is not the radius. because in the general equation on this right side we had r squared. So this whole thing, 16, is actually something squared, and we need to figure out the radius by saying, okay, what did I square to get 16? And if you think, 16 is actually 4 squared, so this equals 16 we could think of as being equals 4 squared. And so we say, okay, this 4 is the radius. Another way of thinking of it is this is the squared version of our radius, right? So to undo squaring, just square root it. So 16 square root, and that'll be the radius, right? Square root of 16 is 4. So now we've got the center and the radius, and now it's easy to graph it. So let's see, -5, 1 means from the center go left 5, up 1. And then radius is 4. So we're going to draw a circle whose radius is 4. And I would suggest like plotting some extra points. The radius 4, starting from the center, means we go out 4 up top and out 4 in all the directions, right? So left 4, right 4, down 4. And then you can use these extra points to help you do a nice circle here. Circle. Okay, it's hard, but you get the idea. And so we're done. We were given the equation, we found the center and the radius, and we used those to produce the graph of the circle. So we're almost done with this lesson, but just a couple issues. First of all, know that, the numbers for these equations aren't always necessarily going to be clean. Like, for example, your center could be weird non-whole numbers, right? Like there's an 8.3. And also the radius could be some non-clean number as well, right? So we got equals 60 on the right side here. And remember that represents r squared. So to get r by itself, as in to figure out what the actual radius was, you'd square root this. And you'd find, okay, the radius is around. And it's some strange number, like 7.7459 around. So definitely not a clean integer, right? And that's okay. In general, circles can have non-integer radiuses, non-integer center positions. Another thing, don't forget what diameters are. So some problems might give you information about a diameter rather than the radius. So here's an example. It says, suppose a circle has center -60, 32 and diameter 24. Write an equation for the circle. So they give us the center, so that part's easy, right? So remember the equation is x minus h squared plus y minus k squared equals r squared. And so for our example, we've got x minus h is -60, so that'll be minus minus, so that becomes x plus 60 squared. And then plus y minus, and then k is just 32, right? So y minus 32 squared equals. But then we need the radius, right, r. But notice that they don't give us the radius. They give us diameter. So just remember, like, on a circle, diameter is all the way across. But radius is only half of that. So in this case, just take the diameter that they give you and cut it in half, right? What's half of 24? Well, that's 12 squared. So then our final answer will be x plus 60 squared, so all this, right? Y minus 32 squared equals, and then 12 squared is 144. And so there we have it. That's the equation for the circle they're describing to us. And remember, if the information they give you is the diameter instead of the radius, don't forget that you have to do something in order to find the radius first. Just cut it in half. So that's the lesson for today. Good luck. And as always, contact me if you have any questions or feedback.